My name is Alok. I'm the ITSI product owner, and with me I've got Martin Weiser over here, who's going to be doing the bulk of the presentation. I'm just here for 10 minutes. We're going to talk about the anatomy of a successful event analytics deployment, implementation. So let's jump into our faces. This is us. You'll see me right now, and then you'll see Martin in a second. So I've been at Splunk for about 8.5 years, and I've been running the ITSI product management team for the last 5 years. Well, about the time the ITSI has been around. And Martin has been on our team as a practitioner, really working very closely with customers like yourselves. And over the last 4 years, a lot of his time has been spent on successful event analytics implementation. So he's got a lot of stuff to go through with you today. So with that, I think you've seen numerous versions of this slide by this point, so I'm not even remotely going to address this slide. So let's talk about what I'm going to cover today. A lot of what I will talk about for the next 10 minutes is what is event analytics. Martin will cover pretty much everything after that. The demo, how to get data in, the correlation to do noise reduction, because again, event analytics is a feature, a capability we have in ITSI in order to do noise reduction and to reduce the amount of noise your teams face when it comes to alarms and events. Implementation plan, tuning, and both him and I will be available for a Q&A at the end of it. So let's talk about what kind of an approach ITSI provides. Let's first talk about, before I build the slide, I want to talk about what ITSI is. So we built ITSI 4 years ago, and really it started off with the service monitoring as a use case. So when you've seen pictures of ITSI, you've seen those service hierarchies, KPIs, glass tables, and so on. But over time, customers sort of told us, hey, we also want an event analytics or event management capability in ITSI. That's where we'd like to start. We want to maybe replace an existing tool, or we want to augment an existing tool, whatever it is. But the core tenet, as we added that use case, remained the same, which is you need to be able to prioritize your investigation. So even if you're dealing with an event analytics capability, you want to be able to prioritize your investigations with some level of service context, so you know what's important and what your teams need to focus on, so you're not wasting time. The other thing is, in addition to prioritization, you need to understand whether something is genuinely broken or not. So even if it is, even if it's impacting a business service or business KPIs, you want to be able to understand that that actually is the behavior, that should or should not be the behavior at that point in the day. And finally, you want to be able to quickly understand what's broken. So once you know that, yeah, for sure it's broken and this shouldn't be behaving like this, you want to understand, what exactly is broken and get to the root cause. That's really what ITSI is about, regardless of what use case you're using ITSI for, whether it's service insights or event analytics or infrastructure monitoring. So let's talk about the 3 pillars of monitoring data. These come up a lot: logs, metrics, and events. In the morning, we're talking about logs, metrics, and traces. From an ITSI perspective, we're talking about logs, metrics, and events. All 3 are equally important to be able to actively monitor your environment. But today, we're going to talk about events specifically. And I'm going to preface this as what is an event, because you're in a Splunk conference, and I'm sure you're hearing the word event data, machine data all the time. So we want to distinguish events from logs, and I'm going to go through that in a second, just to clarify what we're talking about. So what is an event in the first place? When we say event in the context of ITSI, a show of hands of people who know what a notable event is. That's what it really is. So for those of you who don't know what a notable event is, I'm going to explain this slide a little bit. An event in ITSI is more akin to an alarm or a persistent alert, which has some key characteristics. There is some sort of descriptive message that comes with it. There are certain sort of set fields like title, severity, and description itself, and maybe even the host name that it was associated with, and so on. So there is a set of required fields to really understand where this event's from, how important it is, and so on. And then finally, it's also, obviously events are used to determine health. So if something's broken, an event tells you that something is broken. But what our customers have been complaining to us about, not about our products, but the tools that they've been using, is how noisy their event storms really are. And so the whole purpose of this presentation is to talk about how do we use ITSI and ITSI's event analytics capability to reduce event noise. So in other ways, you could call it alarm noise, but that's the type of event we're talking about. In general, at Splunk, when you say the word event, it could mean any type of log data. But in this context, we're being very specific. We're talking about notable events. This alarm data or event data can come from pretty much anywhere. So people have had some misconceptions about ITSI that, hey, do you need to set up services to get all these events in and so on and so forth. For the event analytics capability, you can pull that data in from any of those sources, and any sources really, any type of alarms, any tool, and you don't really need the service construct to use event analytics. It adds to it adds a lot of value if you have services and service structures, but just to do noise reduction, you can just pull that data in from a lot of these different tools, and you can do a lot of event analytics with that. So what does an event look like? I'm going to build this slide. There we go. This is kind of what an event looks like. So if you look at it, it's got we've highlighted some key fields that in this particular Nagios health check event example will always have. It'll have a name, it'll have severity, it'll have a reason. That's your description, for example. Similar events from different tools will have a slightly different structure, but will have very similar fields. So this is what an event looks like. It is a change in a status from one state to another. Often you will care about them because you care about something that broke or something that cleared itself, became healthy again. Now, when we talk about event management tools and events themselves, the truth is, why do we care about this? Because events have become very noisy over the last few years. So this is obviously a diagram we picked up. But if you look back all the way back in time, if you think back in the early 90s, late 80s, the number of devices that any organization had were very, very few. So just doing basic alert management was not that difficult. As things got more complicated, early 2000s, mid 2000s, mid 2005, etc., you still had the active use of products like Netcool Omnibus and other event management tools like that, where you applies rules to really reduce that event noise, but you'd have to now build tons and tons of rules to be able to reduce that noise. So now the additional problem is that now you're managing rules in addition to dealing with noisy events. And so there's extra layer of management and complexity with these tools. So there's never a silver bullet, really. Now we're getting to a point where even those tools don't really deliver that kind of value. So you want to have a solution that's able to reduce that noise with minimal rule creation and rule building and stuff like that. So that's the problem, the challenge that is in front of us. And so with that, I'm going to go through this one slide and then one more slide, and hand it off to Martin. In ITSI, as I talked about it, we introduced event management in the second version of ITSI, notable events itself. Actually, that's the first version of ITSI. We introduced the aggregation policy, which Martin's going to talk about today. Now, that Conf 2016 is pivotal because that allowed customers to use ITSI for event management, for event analytics, to be able to reduce that noise that they've been complaining about. In 2017, we introduced a better way of noise reduction, machine learning essentially. Our feature is called Smart Mode, and it does real-time noise reduction in ITSI. And then finally, in 2018, we introduced a significantly enhanced console to be able to deal with the volume of episodes, as we call them. We moved away from the word event, and we said a clustered view of events is called an episode. It's a cluster of events. And then finally in 2019, as customers have been adopting this more and more, we've been investing a lot of effort, resources, in ensuring that our integration with ticketing systems and other products like that is robust and well built out. So our ServiceNow integration, for example, is obviously very popular because the immediate thing you do after creating an episode is to create a ServiceNow incident, have it link back to your ITSI instance. So that if you close one, you close the other, that kind of a thing. So that bidirectional ticketing integration is also something we introduced for ServiceNow, and we will be introducing it for BMC Remedy. So with that, I've talked about this a little bit, so I'll just cover this very quickly and then I'll hand it off to Martin. So ultimately for event analytics, what do we add? Service context to contextualize and prioritize. That's the optional component. Martin will talk about how valuable it is. Artificial intelligence to help reduce that noise. And remember, we're running on Splunk, so our goal is always to be very, very scalable to reach those ridiculous number of events that some customers have told me, like 8 million events in a 2-week period or a 1-month period, whatever it is. Anything beyond 50 and a human mind can't really handle it anyway. So we're talking about how do we get that number down to something that humans can deal with in an active fashion. So with that, I'm going to hand it off to Martin, who's going to talk to you, who's going to do the demo for you and other things.
Hello, thank you, and welcome for joining us today. So let me jump into the demo. And let me zoom in a little. So as Alok said, when we talk about event analytics, when we talk about event management, we don't talk about this here, which is a service analyzer-based view. We don't talk about the service insights portion. We also don't talk about the glass tables. We don't talk about, the custom visualizations within ITSI. So I'm going to click those away. But what we are talking about is we are talking about the episode review. So if you think of all the priority one systems you guys have in your environment, there may be 5, there may be 50, there may be more than that. Probably all of those warrant to go to a glass table. But besides that, you probably have hundreds, if not thousands of applications that run in your environment. When stuff goes wrong, you want to know about it. And, just to be honest here, how often is it the fault of the database? It's pretty much every single time. So I have my DBA friend Carlos sitting over there. So let's pick a little bit on him. But basically what we have is we have a bunch of database alerts in our environment. So let me drill into those. So as Alok mentioned, in a perfect world, we do have a service context. If we have a service context, we can display the parent service, we can display what is dependent on that, we can figure all of this out. But even if we don't have that information, we have all the other stuff in event analytics. So we have an alert timeline that shows us how many alerts came in here. We see that there's 73 alerts that all got grouped together, that all got clustered together. From here, we can very quickly figure out, okay, what's a potential root cause, right? Can we drill down? And it looks like, based on the data that we have, the possible root cause may be the disk on this particular SQL server basically filling up. Now, if I'm an analyst and I look at this, the next thing I would want to do is I would want to see, okay, what did we do in the past when we had similar types of these episodes? So now, as Alok mentioned, we have this similar episode finder. So we can drill down into what other episodes exist either with a similar title, or we could drill down and say, okay, let's get some additional information about this episode and potentially grab the host name, which other episode did we look at that had similar data, and we immediately see a similarity score. So we can drill down, figure out what was done in this context here. And then at any point in time, we can basically go ahead and perform actions on that. So all your event management folks in your operation centers are gonna be very, very much focused on very quick remediation. If they are not successful with the remediation, at that point in time, they'll shoot it over to ServiceNow. At that point in time, they'll shoot it over to BMC Remedy. Now, one of the nice things about event analytics is it's also fully integrated into the Splunk app for infrastructure. So if I drill down into this event and basically look at which host was affected, I can see all the metrics and everything in real time. So I kind of combine the one static event with the real-time streaming data that may be coming into my environment. So let me jump out of the demo here and basically let's talk about how you get all this goodness. So the first thing you need to do is you need to make this data available in ITSI Event Analytics, and there's 3 ways of doing this. If you have KPIs and services, it's as easy as turning on, for example, anomaly detection. So check the box for anomaly detection and you're off to the races. Or you can go ahead and do something around the terms of multi-KPI alerts. So we'll cover that in more detail. But those are ITSI native methods on how you can get the data in. The most common approach is a Splunk native method, which is basically doing a correlation search. And in there, you do your event suppression, you do your enrichment, and all of the stuff that typically happens as you process those notable events, as you turn them into episodes. And then if you are one of the lucky customers that has literally millions of those a day, which means that you're probably working for a large telco provider, then at that point in time, we allow you to shoot the data in an even more efficient way through the HTTP event collector. So let's look at those things in detail. So multi-KPI alerts allow me that if my maturity level isn't good enough for doing predictive analytics, and we have a lot of customers that really struggle with this because they don't have processes in place for things that aren't broken yet. So they have good processes in place when it's broken, but they really struggle with, hey, your system's going down in 10 minutes. They don't know what to do about that. So this is an interim step. So what this allows you to do is, basically after an outage, after an impact, you can go ahead and say, okay, here were the KPIs that we had, and this was the state that they were in. Anytime I see this again, I want to be proactively notified. So you have this wizard-driven approach that allows you to very quickly, very easily build those notable events. Now I'm going to spend a little bit of time on correlation searches, because that is the piece that most customers leverage to get the data in. So if you don't have service context, if you don't have services, if you don't have KPIs, but you have a bunch of alerting tools, from APM tools to various infrastructure management tools to cloud management tools to various virtualization tools, you want to make sure you bring this data into a Splunk index and then build a correlation search to get it into ITSI. So that's the rough process flow. But besides that, you also want to make sure that you do your enrichment and you do your suppression there. So in the search, in this search bar right there, you want to make sure that if a device is in maintenance mode, if there's a ServiceNow ticket scheduled, for example, for this particular device, that you look up, you do some basic lookups in Splunk to figure out, do I suppress this event or not? If you bring in CMDB information, you want to make sure you enrich the data and say, okay, what's potentially the data center that this is in? What assignment group, what particular group is responsible for this particular configuration item? So all of those things are super important. Typically what customers have is, large organizations have 30-ish to 60-ish of those correlation searches. So typically a correlation search is very specific to a data source, meaning the correlation search for Nagios may be different than the correlation search for AppD, may be different than the correlation search for SolarWinds. Now, this is also your first line of defense. So we have a lot of customers that bring in every single flipping port message. This isn't, the best use of Splunk to get all this data in, clutter it up, and then send it to the rules engine. So if you want to do something like that, you're much better off running stats commands or basically using the power of SPL to basically get this data in. Like we had 47 up messages and 93 down messages on this particular port. So be creative in the creation of those notable event correlation searches. Once you define the correlation search, at that point in time, you need to define what you actually want to display in the notable event. So in there, we have basic field tokenization. So any single field that you have in any message, in any Splunk event, is fair game to be presented in the notable events. Now, I mentioned before, for high volume customers, we also by default install what is called the HTTP Event Collector token. So you can go ahead, shoot the events directly into the HTTP Event Collector and basically have the information for you available in real time. The benefit of that is that on the one hand, you basically bypass the search delay of the correlation search, so you're saving a minute. The disadvantage is that whatever solution you have that processes those events needs to do all the enrichment for you. You can't just shoot it in and then do the enrichment afterwards. You basically need to shoot it in a way, at least if you use the tracked alerts index, which is one of the summary indexes, you need to shoot it in a way how the data is already enriched. So for our high volume customers, this is the method that they are using. But again, at the same time, always keep thinking, I get 5 million events and my operation center is 10 people, the math just doesn't work out, right? So you want to make sure that whoever handles those events is capable of handling the volume that you're actually getting in on the front end. Now here are some very common data onboarding use cases. Let's say you are responsible for measuring, the reliability of 47 refrigerators in a particular warehouse, right? So the refrigerators are going to send their events to some kind of persistent storage, some kind of SQL database. You're going to pull this data through SQL, through DB Connect into a core Splunk index. And from there, you're running your correlation search and basically converting it into ITSI. Now, whether or not it's a refrigerator or a Docker container or, a virtual machine, they all follow a very similar path. Now, if you literally have thousands or hundreds of thousands of events, then this is what we see a lot of telcos actually implement. So all of their events basically subscribe to a Kafka bus. We have different topics that we listen to on that bus, and then we shoot the data through the HTTP event collector into an entire index bank, and then make that data available into IT Service Intelligence. So once we have the data in, the next most logical step is we need to do something with that data. So the first thing we want to do is we want to reduce the noise. So in this little example here, I have a host down, I have another host down, and I have a host up. So the host up message should actually clear the host down message, so my analysts don't waste any time looking at the host down message when there's a host up message right afterwards. Now, what should remain on the console is the one host that didn't get an up message yet. So this is all done in the event correlation, or in the notable event aggregation policies. So we do that through aggregation rules, so through notable event aggregation rules, and their sole purpose is, on the one hand, to clear the noise, and then on the other hand, to basically perform automated actions. Now, this is where we see a lot of customers take a wrong turn. So event reduction or notable event aggregation policies are not the same as correlation searches. So while you may have a correlation search for every data source, you may just need event reduction rules for your entire organization. So most customers literally live with one aggregation policy. Some of them have a blocking policy, which is for maintenance items, where they say basically don't create an event in those scenarios, or use one of the predefined states like pending to basically not confuse the operations center staff. The really mature customers may have like a third one for no-touch type events, meaning for stuff that comes in that immediately gets handed off to automation for self-healing. But outside of that, there really is no reason why you should have more aggregation policies. So when we see implementations where they have a dozen of those aggregation policies, it's very often that they didn't fully understand the concept. Now, that aggregation policy basically gets applied as the data flows into Splunk. So we have what's called the indexed real-time search that basically processes that data. And at that point in time, one of two things are happening. It identifies a policy that can be applied to that event. So let's say, okay, for a database, table space ran out of disk space, let's run this automation script. So there may be a policy out there that does exactly that. So it applies that policy. Or if it doesn't find any matching policies, it goes to the default policy. This is also where Alok mentioned where we have a lot of the machine learning, the event clustering built into ITSI. So it compresses all the events into bigger chunks, into bigger groups, into bigger episodes. So with that, we see a common operations flow that typically looks like this. You have your entire environment, it gets monitored, all the issue detection, everything happens in ITSI, but the buck doesn't stop there. So once it is in ITSI and the operations staff tries to perform certain recovery actions and they are not successful, at that point in time, it has to go somewhere else. It has to go to an official record to actually do something about it. So this is where we see different routes depending on whether or not the company is more traditional ops focused or whether or not the company is more DevOps focused. In the DevOps world, it very often goes into notification tools like PagerDuty, Xmatters, obviously VictorOps, OpsGenie, and those type of things where they can collaborate right away there. But in a traditional ITIL world, we often see them going into ServiceNow, BMC Remedy, Sharewell, all the other ITIL incident management tools. And we have integrations for many of them, so at least for the most common ones. So now that we talked about those two major components, getting the data in and reducing the noise, let's take a look at what do implementations look like. So very rarely do you get the luxury of implementing event management or event analytics greenfield. Very typical replacements are exactly that, replacements. So you have an existing system out there that you want to replace. So the first thing you need to do is you need to look at what does the existing system do, like figure out which systems feed that existing, let's throw something out there, that existing that cool environment. We have SNMP traps, we have APM data, we have Nagios data. So you basically identify all the different data sources that feed that existing system, and you want to make sure that this data also gets into Splunk, because otherwise you have no chance of replacing it. After that, you want to figure out, okay, what are the existing aggregation or correlation capabilities? Do we suppress them when we have maintenance rules? How do we deduplicate, or how do we suppress certain events under certain conditions? Like we talked about this flapping port a minute ago. And then how complex are those rules? Because you want to make sure that those rules are things that you can fairly straightforward, fairly easily implement in the aggregation policies. And then again, it doesn't stop in ITSI. Typically, you need to figure out where does it go from there. So make sure you have your reporting gateways identified. Does it go into some service management tool or somewhere else? Now, when you replace those tools, there is a lot riding on those tools, meaning if you do a bad job, this can very quickly turn into a career-limiting move. If you miss a P1 alert and you built the rule wrong or whatever, this is not a good place to be. So what you want to do is you want to minimize the risk. You want to stand that new system up in parallel with the old system. So you implement alongside the existing infrastructure. Your operations center has a lot of tribal knowledge, so they will tell you that, oh, there are certain events we don't even look at. Like we have a customer that literally gets on a daily basis 20,000 health check failures from F5 load balancers. Nobody looks at that. Like, why bring this data in to begin with? But you wouldn't know this because you would think, well, somebody may look at this. So you want to involve your operations center in all the phases of that project. And then the way you typically structure this is you start out with a proof of concept. You, in that proof of concept, validate some of the basic assumptions that you made, like can we create the ticket in ServiceNow? Can we consume the App Dynamics alerts? Can we consume the Nagios alerts? So after that proof of concept, you go into a minimum viable deployment. And then from there, you go into full data onboarding, full production rollouts. Now, unfortunately, it's not, year 2000 anymore. So many of those implementations actually need a business case. So back then in Y2K, we just did stuff because we could. Nowadays, this isn't the case anymore. So think about why you want to replace your existing solution. We have customers out there that literally run on like Red Hat 5, stuff that's like out of support for 8 years. That's a viable reason why you want to replace it, right? You want to go to a solution that's supported again. You want to potentially, you grew, you had a lot of acquisitions. You want to reduce the number of events. Those are all valid reasons, but don't start the project without a really good, business reason. Then go ahead, build the pilot, build the POC. Go ahead, go for the minimal viable deployment. Make sure you have all the major components at that point in time deployed. So this timeline up to phase 2, depending on the size of the organization, can be really, really quick. Like we have some customers that are able to finish phase 1 and phase 2 literally within a calendar quarter. And then you onboard your operations center. So this comes with end-user enablement, comes with training, making sure that the roles are configured, that the teams are configured correctly, and you're off to the races. So at that point in time, you're live on the new system. The key there is, with the minimum viable deployment, you want to make sure you validate your alert count. So if your old system processed 4,792 events, you want to make sure that your new system has the same event count, so you are not missing or suppressing or swallowing, some weird events there. Now, over the last couple, 3 years, when we had those implementations, we always seem to hit the same technology add-ons. So the technology add-ons that are super common are SNMP traps. So SNMP traps, cold start traps, all of those things are very common data sources. Nagios, another one. Service management tools to get the data in or to enable bidirectional ticketing. Again, super common data sources. And then obviously all the different cloud providers have their own technology add-on. So we want to make sure we take advantage of all of this and bring this data into Splunk. So putting this all together here. So on a single slide, first you start out reviewing and onboarding those data sources. It does not make sense to bring in a lot of Splunk expertise, worry about aggregation rules, worry about all that stuff if the data sources aren't there to begin with. Once you have the data sources there, then you identify the aggregation logic and the external integrations, like where is my CMDB data stored? How do I get the CMDB data in there? How can I do the lookups? How can I do the enrichments? Then you go ahead and basically do an operational analysis, because your old tool probably was built on processes that are at least 10, 15, if not 20 years old. So there's for sure potential to speed up the workflows that your operation centers use. So looking at workflow improvements should definitely be part of that project. Then you build out the POC environment, you pilot the system, you test it out, you look at all the major capabilities, you incorporate the feedback you get from this POC, and at that point in time, what you want to do is you want to build out your production infrastructure, and the most important step is you want to have a phase where you do alert accuracy validation. So again, if the number of alerts is different between the old system and the new one, that's not necessarily a good thing. If you are missing, if you think you're reducing the events, but in reality you are missing them, you know, like I said before, this can be a career limiting move. And then when everything looks good and checks out, at that point in time, you want to onboard your teams, and you want to onboard them in a way where they can actually leverage it, where they can actually use it. Now, what are some of the common issues we see in the most recent releases of ITSI? So we had our fair share of version mismatches, and that is purely on us. Like, we had Splunk core releases that weren't really matching with the right configuration or the default configuration of ITSI. So what you want to make sure is you check the compatibility matrix. We still, we test this on very recent ITSI releases, very recent Splunk releases, go back a couple releases, but we don't test this on like Splunk 6.3. So if you guys are running an old infrastructure on your search head or your indexers, let's make sure that the version compatibility is actually in place. There are many features we take advantage of on the Splunk Enterprise platform that have to be in place for ITSI event analytics to work. So the second piece that I wanted to throw out there is Java. So I don't know how many customers I'm running into, but basically they get the events in, everything looks good, but then those events never show up. So Java in some environments isn't necessarily installed by default. There is very little, UI, I guess, prompting that we do on the ITSI side that says, hey, Mr. Customer, you're running this on an unsupported version or on a non-Java installed search head. So make sure that Java is there, because without that, you're basically completely out of luck. So let me wrap this up here. So in this session, hopefully, we covered why event analytics is important, because it's basically for all the stuff that you don't have time to build glass tables or service analyzer environments for. We reviewed how to get the data into ITSI. So again, correlation searches, main one, HTTP event collector, and multi-KPI alerts. We looked at how to reduce the alert noise. So we didn't really demonstrate that too much, but at the same time, you guys saw the number, like the 78 or 38 or whatever it was. So all those individual events got grouped together into a single episode, so a single entity that your operations center has to take a look at in order to basically work those type of issues. We talked about how to operationalize that model and what the operational models typically look like. And then we looked at, how could we structure a project to actually replace one of those legacy platforms. And the best thing for you guys is we may get you out 5 minutes early for drinks, but that depends on the number of questions. So with that, let's jump into the questions. First question back there. So the question was, there's a lot in Splunk ITSI that is Python-based or in Splunk Enterprise. Why introduce the Java dependency? So the answer is twofold to that. You cannot control the luck of the engineers, that's one thing. But we also use Java for one of our machine learning anomaly detection algorithms. So it's not the only component that actually uses Java. And Java has some really, really powerful grouping capabilities as far as machine learning libraries that we didn't have available on the Python side. So in order to do this with Python, we would have to go with like pandas and some additional packages, which would have made the ITSI installation package way larger. Okay, any other questions?
For systems that you're monitoring that require custom acknowledgement that messages were received, are there any built-in components to handle that or customize an acknowledgement?
So the question was, if the system that sends you the data needs an acknowledgement, is there anything in ITSI or in Splunk to begin with that would allow you to facilitate that? And the answer is I don't know. So if it can send REST and HTTP, we can go and basically turn on acknowledgement or turn that off. But if it just sends, so this is a configuration of the HTTP event collector where you can basically configure that and turn that feature on or off. But if the system, just logs to a file or whatever, I mean, there's, obviously no potential for acknowledgements at all. But if they can send through a HTTP post directly in, then we can definitely control acknowledgement.
Okay. So in the HEC acknowledgement, it looks like that's a particular JSON string.
Yep. So the question was, for the AGC data format, can that be customized? No, this one is static. But depending on your, I guess, acknowledge or not acknowledge, your return code, like your HTTP return code, as well as the error message, will reflect, if something is wrong. Let's say you send a JSON and it's missing the event ID or it's missing a critical field that ITSI is expecting. Then at that point in time, it will say this is an invalid event format, and it will tell you which potential field is missing, or it will tell you that you are specifying a field or invalid JSON format or things like those. Okay? Okay? Yep. So the question was, is there a common information model for notable events? The answer is there is, but we are not taking advantage of that. And the reason for that is notable events or events in general are very different, right? Like you have the little, very aggressive message that comes from the mainframe and says, abandoned job, with a severity of critical, right? Like very few data fields. But then you may have an AppDynamics health check alerts that includes like 47 telemetry, fields on top of that. So the common information model would have to account for all of those different permutations. So what we decided is, hey, we don't want to drop the cardinality. We don't want to drop all of those different fields into in ITSI. We want to take as much data as we can because it's obviously one of our major differentiators, and it makes the operation centers way more productive to actually see that stuff. However, for certain other areas, like Alok was mentioning the bidirectional ticketing integration, right? Like if we send a ticket to ServiceNow or BMC Remedy, a lot of that information is using the common information model, meaning I have a ticket status, I have a ticket ID, I have a ticket description, I have a short description of that ticket. So there's a handful of fields that we do there. But even there, it's a little bit tricky because like ServiceNow has, I think, out of the box 2 levels of categorization. BMC Remedy has out of the box like 6 levels of categorization. So the question is, where do you stop with the common information model, so you can still take advantage of that, but at the same time, not lose any of the data cardinality. Okay? Any other questions? So the question was, are there out-of-the-box aggregation policies, or do you have to build it yourself? And you'll actually like this. There's one called the default policy that groups everything together. So at the end of the day, you just have a single alert to manage. I'm not sure that's very useful, but that's what we have out of the box.
So let me add to that, actually. So we have a couple of blog posts which show you how to do out-of-the-box correlation searches. We don't have out-of-the-box aggregation policies that are set for like, hey, this is for ServiceNow or this is to do that kind of stuff. But we got this. I'm the product manager, so I can say this. We got on the roadmap. Rather, what's coming out tomorrow is a set of features called the content packs for ITSI. Now, they don't have aggregation policies yet, but in future, those content packs will have aggregation policies as well. So we're working through what those should be, and they're going to be around things we've seen. So getting those content packs out for aggregation policies is not going to take like 10 months from now. It's very much updating it within a month with additional aggregation policies for event analytics.
And actually, the blog posts are a great source. So for like AppD or New Relic, we not only have the blog post, but the blog post actually includes the notable event aggregation policy as well. Same with like Nagios data or Netcool data, right? So all you do in that case is you take, if you want to onboard Nagios data, you basically take the data, you restore the backup file that's part of the blog post, and it builds the correlation search for you, as well as the aggregation policy, but it's limited to the data sources that we see most often, which is roughly a handful.
We're going to try and put those blog posts into the content pack. Basically, that's the first version of it. So.
Okay. Nope, this was me. This is like 5 more minutes and then shut up. Nope, go ahead. So the question was, if you have an alert that matches multiple aggregation policies, what does ITSI do? And the good news is that there is no hierarchy of aggregation policies. So if you have an event, and again, you want to be 3 or less on the aggregation policy side, but you have an event that matches like some blocking policy and potentially some automation policy, it will actually be used in both. So if you have a group that says 7 on one and 9 on the other, and you get one new event, it may say 8 on one, and it may say 10 on the other, even though a single event only arrived. So in the evaluation, it basically determines how many aggregation policies fit, and then it applies all those aggregation policies to that new event. But again, you want to make sure that all the filtering, all the deduplication happens as much on the front side as possible, which in this case is typically the correlation searches. Okay? Say that one more time. Okay, so the question was, can you run ITSI without setting up any notable events? And the answer is absolutely yes. So we did many service insights, glass table exercises where we visualize a service in real time that basically either doesn't alert because it's such an important service that the SRE looks at it 24/7, or that alerts not through ITSI mechanisms, but actually sends it to some other tools, right? Like to a Netcool solution, to a HP solution, to a BMC solution, right? So those are all fair games, but you can absolutely have glass tables, deep dives, all of that without having any kind of notable events implemented in the system. Yep.
No, so so the question was, it's not a required best practice to have notable events set up. That's the question, right?
Well, I mean, it's not a best practice. It's not kind of best practices to implement the ITSI setup.
No, this is more of a business. So the follow-up question was, is it best practice to use it or not? And it's more of a business decision, right? Like if you are happy with looking at real-time monitoring, right, and you look at a glass table, then there's no requirement, right? But if you want to do more, if you're running out of screen space, right, because you have one monitor basically looking at this one glass table for this one application, if you want to get all the events from your other 3,500 applications, you kind of need a mechanism for that. So it's not a requirement to use that in ITSI, but as an organization, you obviously better have some place where you actually perform this function.
It's more of a question of which use cases in ITSI are relevant to your business. So sometimes customers don't do anything with event analytics, they'll do everything with service monitoring. Some customers do both, and there are some customers who do only stuff with event analytics, nothing with service monitoring. So, yeah.
Cool. Final question, last minute. No, I didn't want to ask you, sorry. Go ahead.
Can I create like families of message groups or families of nodes of
So the question was, can you create families of specific messages? And the devil's in the detail there. So we see a lot of customers do that for mainframe messages, meaning, if this job fails and this job fails and everything, then you want to group it together, right? Because they all kind of look the same, they all have similar error messages. So the answer to that is absolutely yes. But then for other type of events, we actually don't necessarily want to create a family, like we don't necessarily want to create all the database alerts together. We kind of want to take the application alerts and the database alerts that caused it and group those together, right? And they look very different. Like one may come and say, hey, I got a JDBC drive outage. The other one may say my table space is full, or my queries timeout or whatever. So it depends on how your operation center works. Technically, it's definitely possible, but we don't see that in reality implemented too much outside of mainframe messages. Okay? Thank you very much. Alok and I will hang out here for another 5 minutes.